All right, we want to graph the point and its reflection. The easiest way to do that is maybe to graph it, and then you just flip it over the x-axis. So this was your problem of the day. I'm just going to put this up. That would be 5, 2, flipped over the x. 1 or negative 1, 0, flipped over the y. This one is also flipped over the y. One thing that you might want to notice when they're flipped over the y, it's the x that changes signs. And when it is flipped over the x, it's the y that changes signs. So our essential question today is, how do we graph y equals f of x plus k, y equals f of x minus h, and y equals negative f of x compared to the parent function f. So this would be your parent function. This one, with that minus h, you're going to be shifting it either right or left. Here is going to be a reflection. Oops, I'm sorry. That f of x plus k would be a shift up and down. I think I missed the k. So this was supposed to be kind of a work with your partner, and we're going to compare the graphs. I'm going to go ahead and skip the work with your partner right now, since that was kind of a self-exploration, and kind of you needed to figure some things out during class. So on that one, what you needed to realize was that k shifted it up or down. The h shifts it right or left. And the negative sign in front flips it. So here are some key concepts. You might want to take a second and pause so that you can get these into your notes, because I'm probably not going to give you enough time to actually write it as I am speaking. So we're going to let f of x equal 2x plus 1. And remember, f of x is just a fancy way of saying y. So it's the same thing as y equals 2x plus 1. So we've got a linear function here. We want to write a function g, and that's just designating that it's a different line whose graph is a translation 3 units down. So what you would have to do is you'd have to subtract 3 units, or minus 3, from each output. So taking f of x and you're minusing 3, or adding negative 3, it's the same thing. And you're going to get 2x minus 2. For b, we want to do a translation 2 units to the left. So we're going to have to subtract 2 units from each input. And the input is going to be paired with the x. So in that parenthesis, it'll be x minus negative 2, or x plus 2. And you're going to end up with 2x plus 5. Another core concept, you might want to pause for a second to get those down. Reflection in the x-axis, reflection in the y-axis. All right, so we want to write a function g whose graph is a reflection in the x, and then h, reflection in the y. Well, reflection in the x changes the sign of each output. So your output would be f of x multiplied by negative 1. Now that we know what f of x is, it's the absolute value of x plus 3 plus 1. So you substitute that in, distribute that minus sign, and that's going to be your final answer. A reflection h in the y-axis. Let's go ahead and do that one. That one, you change the sign of each input. So that means my x is going to be negative. So we put a negative sign in front of that x. Distribute. Absolute value x minus 3 plus 1. These should probably be you do. So you might want to take a second and pause, give these ones a chance to do them yourself, and then check your answers. It says graphing calculator, use Desmos. Be careful with those signs. It's really easy to make a mistake with your signs. That's why it's always a good idea to check your work. Another core concept, what that's saying is if you got a greater than 1, it's going to be going up faster. A between 0 and 1, it's not going to go up quite as fast as your parent function. So let's go ahead and do an example. We've got f of x equals the absolute value x minus 3 minus 5. When you write a function g whose graph is a horizontal shrink by a factor of 1/3, and then we're going to do the same thing for a function h whose graph is a vertical stretch by a factor of 2. Well, when it is a shrink, you're going to multiply each input by a value of 3. All right, go ahead and try these on your own. See how you do. All right, let the graph of g be a vertical shrink by a factor of 0.2, followed by a translation 3 units up. Oops, sorry. First, write the function that would represent the shrink, 0.25 times f of x and then you're going to add 3 to that output. So it would just be 0.25x plus 3. All right, word problems, everybody's favorite. You're going to design a computer game. Your revenue for X downloads is given by f of x equals 2x. Your profit is $50 less than 90% of the revenue for X downloads. Describe how to transform the graph of f to model the profit. What is your profit for 100 downloads? So, always you want to understand the problem. On this problem, I'd probably read it a couple times. That profit is $50 less than 90% of your revenue. It can be a little bit confusing. Then we need to make a plan. Plan here is we're going to write a function that represents the profit, function p. Then we're going to use this function to find the profit for 100 downloads. So our profit is 90% of the revenue minus 50. So 90% of the profit, and it says 50 less, that means that you're going to subtract 50. Go ahead and simplify the math. You just put in 2x for that function and multiply that by 0.9, and you're going to get 1.8x minus 50. for 100. Just going to substitute 100 in there, and you get 130. So you get a profit of $130 for 50 downloads. And again, we always want to look back. Does our answer make sense? It does. That would just be negative absolute value of x plus 6. In our previous example, if f of x is 3x, you would have to substitute 3x in instead of 2x, and your profit would go up to $220. I like this question a lot. This is going to be something very similar that you might see on a lesson quiz. So it's got a shift 2 units to the right. It's being shifted 3 units up, and it's got a vertical shrink factor of 1/2. All right, that is it. Hope you enjoyed.